So let's go ahead and jump right into it. A little bit of a review from yesterday. Again, in yesterday's video, we broke it down into two sections, A and B. A, it was a review, but more so it was linear models. So your response variable was quantitative, whereas in B, your response variable was categorical. More specifically, it was categorical binary. So what we're going to do is continue on that pathway, right? Where our response variable here in this particular situation is going to be binary output. So I already have the code. I'm going to run through this at least this part real fast. This is a review of yesterday. So we'll go ahead and run this. Okay, great. Suppress the startup messages. Great, fantastic. We're bringing in the supermarket business data frame. We're going to change the column names so that the spaces are underscores. Find the mean of the profit made. And we're going to make it a dichotomous variable. We're going to create a binary variable in terms of profit, whether it's good or bad, based on the mean. If it's greater than or equal to good profit, less than, it's going to be bad profit. Binary factor is not that important right now. It's just, okay, as factor. Okay, great. Then what we did from there is we determined the mean and standard deviation of the advertisement with regards to this profit. Long story short, if you spend a lot of money on your advertisement, you make good profit. Okay. From there, we looked at the plot between advertisement and promotion spend just so we can look at it, but we noticed that there's no relationship. Fantastic. However, when we sit there and talk about, when we refer to the binary profit, well, we notice that there's a clear difference somewhere around $700 or $75,000. When you spend more than $75,000, you get good profit in terms of advertising spend. In terms of bad profit, that only happens when you spend less than $75,000. Great, fantastic. All right. So one of the biggest things I want to note is, let's say you have a new supermarket. Boop, boop, boop. A new supermarket, let's say, is right about. Let's choose a color, a different color. Let's say it's pink. Pink is. Let's say purple. Let's say a new supermarket is right around here. Okay, so what we are going to propose, what we're going to suggest is to use this algorithm called K nearest neighbors. All right, so based on my neighbors, I'm going to determine which classification should I use. So let's say I choose the closest two neighbors. I'll say are these 2 points. Let's use a different color. Oh, that's not a good color. That's not a good. But again, let's say our point. Let's pick a point again. The point is right here, right? And we're going to look at these 2 points as our neighbors, our closest neighbors, and these 2 points will determine which color this will be. Okay. Likewise, if we had another point, let's say another point, let's say it's right around. And let's say our K is equal to 2. We're going to look at these 2 points and say determine what this point would be based on these neighboring 2 points. Okay, this particular example is not the best in the sense that it's kind of clear what to use, what points it would be. But if it was near a situation where it was like a tie, the algorithm will randomly choose which of the classifications to select. Okay, that's where you can find some random error, especially in this example where it's not so clear cut. Okay, we won't go over the math, but the idea is whatever's closest. There's a math equation that determines closeness. Whatever's closest, we'll use those classifications, right, as good or bad credit to determine what is the new classification for this new supermarket. Okay. All right, so with that being said, let's talk about this algorithm. This algorithm actually takes a little bit of data manipulation. Okay, it's not crazy manipulation, but it's data manipulation nonetheless. So what I'm going to do is I'm going to go ahead and do a copy and paste based off of the video that we saw previously in the Machine Learning A and split our data up into training and test. Again, in that video, I specified why we would do so, and I'll do it again here. So what we want to do is have a model. We have a model, and we want to verify the ramification, or we want to determine how well the model fits on data that we already know the classification for. Okay, we want to be able to split the actual data into two, okay, and use the training data to train the model, and then use that model to predict on the test and verify based on the data that we already have. We already have the response variables for the test and compare with what we predict. If that doesn't make sense, I'm going to show you what I mean by that. So what this looks like is we have to first, okay, again, this is our us splitting the data into train and test. What we're going to now do is we have to do something kind of quirky. Two quirky things. And I'll explain why we do this in a moment. So what I want to do is remove the binary profit, or at least get binary profit from the train and test and save it as a vector rather than as a data frame. So in order for me to do that, I'm going to have to take my training, right, subset. I'm going to zoom in so you can see a little bit better. Okay. Type, and I'm going to use this function called pool. Pool binary profit. The reason why I didn't auto show up because I didn't run this already. Okay, so when I pull it, it's going to create a vector. Well, it's going to pull a vector. Whereas if I did a select, it would create a data frame, and I don't want a data frame. I want it as a vector. Okay, so I want it as a vector. So that's that. And I'm going to save this as the train binary vec. Okay, so just like this. Okay, that's what I'm going to save it as. Then I'm going to do a copy and paste. I'm going to do the same thing for the test data set. So call this test. Call this test. And then the reason why we do this is because the algorithm works in a very interesting, I would argue clunky way, but it's fine. Okay, so we're going to obtain a vector of the response. We're going to obtain the response variable. Obtain a vector, which is the response variable. Okay, that's fine. We'll keep going. Okay, so we're going to keep it as pool. Okay, great. The second thing is that now that I've pulled it out of the data frame, or at least now that I've pulled this information, I want to remove those vectors from the data frame. So ideally take a moment and pause. What must I do in order for me to pull? What function will I use? Or what function will I use to take away, remove it from the data frame? Okay, hopefully you all said select and you do a minus. I'm going to do a control paste or copy paste here. And I'll explain that in this test data frame, I'm removing the binary profit. And then the train, I'm doing the same thing. Okay, I'm removing it. The actual binary profit. That's just the way how the algorithm works in R. Okay. So what I'm gonna have you now do is now you have all these ingredients. You have 4 pieces of information, which is great. And then I call this step 2. We call this remove response variable from data frame. What we're gonna now do is you're gonna install this function called class install. It's called class. And you're going to install, I don't have to install because I already did it. But here, we're going to use library class. And we're going to run the model. So it's KNN. That's the name of the function. So you can see that it automatically corrects KNN. And we're going to first input the train. So I want to actually do something that I've never done before. I'll do that. So train, I can say train is equal to my training data set. So I can do train. Oh, come on, Emmanuel. Type today. Okay. So what I'm going to, actually, I would want to call it R. That's for the R underscore response train. Okay. Because I removed my response variable from this. Is why I'm using this one. And now I want to use my test. And that's going to be equal to R. 1 second. All right, give me 1 second. Okay, rvest. Okay, and then last but not least, this is where now I put my vector, the training vector, which is this component here. My training vector. I give that as my class. So it's called class CL. And then finally, I want it to look at two neighbors. I want to say K is equal to 2. So what this is doing is creating a model based off the training data set, and testing is predicting for the test. It's creating classification for the test. And then finally, it's using the class, or not finally, it's using the class of the training data set based on the two nearest neighbors. So here, I'm just going to name this model A underscore K and N. This is equal to, I didn't run this, I don't think. Okay, good, no error. So now I have my model. What I can now do is something quite nifty. So I'm going to use a table function, and table function allows me to count frequencies. And I didn't say that maybe last week, but that's what it is used for primarily. Model A, K, and N. And what I'm going to do is I'm going to use a test binary vec, right? And so when I run this, I should get a table of classification where we get true positive, true negative, false positive, false negative. Okay, so here I have 6 true negative. Okay, because I'm interested in good profit. 6 true negative, 6 true positive, 0 false. This is going to be a false, so they're predicting that it's bad profit, but in reality, this is a false negative. Okay, false negative, 0 false negative, and 1 false positive. When they're saying it's a good profit, but then it's really a bad profit. If that's not crazy, there's a couple things that we can talk about after we get this matrix. And I think tomorrow we may do a more complicated data set. This is pretty straightforward. It's only 50 observations. Maybe a little bit more complicated would be great. But please, please, please ask me questions if this doesn't make sense, okay? Thank you for your time, and have a great day.